also one of the directors of Earth Observation Australia Incorporated. Just checking that everyone can hear me all right at the moment. So, yes, no.
Yes, I can hear you, Stuart.
Thanks, Helen. David, can you hear me now?
Yeah, no, yes. There was...
Okay, good. Sorry. Okay, that's actually a good test. If anything goes wrong technically, please type it into the chat window or just put your hand up and we'll try and address the problem as quickly as possible. So as I said, I'm Stuart Finn from University of Queensland Earth Observation Australia, which is a national organisation where we look across everybody that collects and uses Earth observation, and it is something that we're trying to diversify in terms of the range of different environments and applications. So that is something which a number of you are involved with. Amy Parker, who's online at the moment, is the Vice President. Yvette Antoine's on the Management Committee. Arnold Becker's been on the committee beforehand. So I've gone out again. Right, hang on. I'll just pause for a second and I'm going to change my audio.
Stuart, the problem might be at David's end. I can hear you fine.
So David, is that clear now?
I can hear you fine too.
Oh, good. Okay, you may hear some background lorikeets and kookaburras, so I apologise for the noise. Earth Observation Australia, as I said, we're trying to diversify that in terms of what we do. This particular activity is the Earth Observation for Government Network, which I'll come to explaining in a minute. I do want to start with some general housekeeping to begin with, and then move into what we're trying to do over this workshop for the next couple of days as well. Okay. So to begin with, I would like to acknowledge the traditional owners of the land and waters on which we're meeting across Australia. In particular, I acknowledge the Turrbal and Yagara people whose lands I live and work on here just to the south of Brisbane. I want to pay our respects to their elders past and present, recognise their current and emerging generation of leaders, and also recognise that they've always been the stewards of the land and waters that we work on, and that we're also working together with them on understanding and developing environmental management solutions as well. So just in terms of housekeeping today, we will be recording the sessions. You'll be able to access the slides and the recordings afterwards, and we will compile a summary report as well of your responses to distribute that as well. I do want to acknowledge Larissa Marfan, who's helped put all of this material together as well. So having said that, again, if there are technical issues, please type it into the chat window. I'm hoping the sound is going to continue to be okay. If it does drop out, let me know. All right, I'm just going to change over to the screen. Okay, so hopefully you can hear me and also see the screen there at the moment. And just a reminder, it's all being recorded as well. So, okay, this is the first in a number of workshops about using Earth observation for monitoring and managing water-related resources within Australia. It is through the Earth Observation for Government Network, and I'll explain what that's actually for in a minute. So if we look at Australia and its immediate environments, we do have a lot of coastal and oceanic and freshwater and groundwater resources that we use Earth observation to look at. Some of these are highly seasonable, like our wet-dry floodplains just to the east of Darwin and other areas. A lot of our coastal urban areas on or next to major water courses, along with a lot of our, I guess, agriculture and horticultural activities in those areas as well. Our coastal reef areas on the east coast and the west coast and offshore are also quite unique resources which depend on physical and biological properties of water bodies to exist. Even in the middle of our more arid areas, the role of surface water and groundwater is critical in terms of habitat and a range of other activities that we have going on in there. We also have water in its frozen form. Our snowpack and its dynamics are of significant interest for a range of reasons, and we use Earth observation to look at them. We have some heavily forested areas with a lot of rainfall and clouds in them, where understanding water in those environments is important. And we have all other environments like our wet, dry tropical savannas, where the seasonality of water affects growth of vegetation. It also affects fuel load and fire. Our urban areas depend on water supply for running a whole range of different services. Our coastal areas depend on various aspects of water and the physical and biological state of the nearshore and offshore ocean to keep them in place. We have a very large amount of transport and commercial activities that uses coastal and oceanic waterways, and some of that can be hazardous at times. The reason for that background slide was just to say that when you look at the environment in Australia, there are a whole range of economic, community, and I guess if you want, ecological, biological activities that depend on water quantity and quality, both above the ground, below the ground, and in our coastal and offshore areas. When you look at who's actually dealing with Earth observation in those areas, there's a whole range of different areas that collect Earth observation data and process it and deliver it as information. This isn't trying to make things complicated. It's really just showing, if you look at where does satellite imagery come from, how does it get processed and used in Australia, there's a range of different groups. If you have a look at Earth Observation Australia, what we're trying to do is sit across what happens across government research and provide a conduit to the space agency to understand what's happening in these areas. A lot of you who are on the call today probably will already work across all these different government agencies, use our national research infrastructure, and work with universities and industry and NGOs. What we're trying to do in these workshops with Earth Observation for Government is look at particular applications, in this sense oceanic applications, and look at the extent of research that's going on across research institutions, private industry, and how that transitions through to operational applications. And the aim is to get a good sense of what that is and how do we link it up maybe a little bit better and use those links more effectively. You can see there's other activities in there like the Cooperative Research Centre, Frontier SI, and others that are involved in what we're doing. So it's starting to get closer to what we're doing with Earth Observation for Government network and looking at oceanic areas. If you look at that line across the top there in red, we've got research. You set something up, you test that it works, get it working in an operational context, which is different for different people, and then get it working at national scales and larger. And those levels across the top there are almost like technical readiness levels, where you're going from zero, which is an idea, all the way through to making things work in an operational context. So Earth observation is continually going through this sort of 0 to 9 stage, whether it's new sensors, new data, new field measurement techniques, new algorithms, And we need good systems for pulling all these things together. If you look at Earth observation, there's a flow, and the oceanic area is a good one. We've got people doing research in all of these different areas. Research isn't just, contained in universities. Our institutes, our universities and governments use our national collaborative research infrastructure capabilities. They make things work there, and then they push it out to more operational applications, whether it's in the Bureau or other places as well. The idea of Earth Observation for Government Network is to start those discussions for going from research that people are developing, whether it's new sensors, new algorithms, new techniques, and how does it get through to being operational in this sense. So as an example of what we're doing with looking at Earth observation applications in the water domain for Australia, here's a context of where we're coming from. In 2019, we held a national workshop with a number of state and territory and Commonwealth agencies and universities looking at, and this is on the far left-hand side of this diagram, what research was actually going on that was delivering Earth observation into operational applications for a range of Commonwealth government activities. And that identified a range of different priority areas where Commonwealth was already serving products in these areas, but they could be improved. So things like vegetation, land cover and land use, water, topography, and fire. At the beginning of this year, we redid a survey to look at, what did people actually need and want to do. That wasn't engaged with a lot. So we've run a number of directed workshops since the beginning of the year, looking at that transition from research to operational products in a range of different application areas, with the aim of more effectively connecting research activities through to delivery of applications and services from them. So what we're going to do with the water series here is we're going to run a set of activities on oceanic applications, this one. We're going to run another one looking at water quality, and then we're going to run another one looking at water quantity. So this is essentially the first cab off the rank. We're going to look at biological and physical aspects of the environment that are measured and monitored from Earth observation. Water quality we'll look at moving into January, and water quantity, both above and below the ground, we'll look at in February. In each of these series, we have 3 sessions. Today, we're starting with session 1 on the oceanic, which is, what are the research directions that people are going in? And David Antoine's going to give you some more background in that context there. The session tomorrow will start to look at, what research applications are close to going from, we know they work over large areas and they could be pushed forward to being used, or that we've got agencies that actually need them as well. And then the final session is about how do we push everything together, ideally to get it working more effectively. We know this isn't going to include everybody that needs to be here. So it's a start of an ongoing process of getting our research and applications and operation groups together. And the output from this will be a transition plan going forwards. So we'll jump into the water workshops for oceanic environments now. This is just the aims. I'm going to say a few more words and then jump to David to present. So what we're trying to do today is at least get an understanding of what are people doing in research and development, pushing through to operational for oceanic applications. And then sessions 2 and 3 will try and link things together. So those are the 3 sessions for this week. Today is, what's there? How can we push research forward? Tomorrow is, what's that push and pull into operational requirements for government? And then Thursday is, where do we go to next to make it happen? So there's the sort of structure of the workshops, you know, what's happening today. We've got a survey. Tomorrow, what's the push and pull for these things? And then Thursday, how do we put it all together and then move forward collectively? This was just an example of the latest workshop that we ran on national crop classification mapping for Earth observation for government. And you can see it brought together industry, research agencies and government, looked at what was required and what was being pushed forward, and then worked out a way forward. Part of this was actually engaging with a national coordination body to help build a process for doing that. I'm not suggesting we come up with a national coordination body for oceanic products. This is just one of the ways that, you know, in this case, the people doing crop classification decided to go at it. Here's the outline for today. I've just done a bit of an overview. I'm a little bit over time. David's going to talk about current and future Earth observation applications for the oceans. We're then going to go through and just introduce that survey form and start to talk you through filling that out. David's then going to talk about some case studies. Then we'll go back into filling out the questionnaire and have a bit of a discussion as well. Probably have a break at that. And then essentially just before 3 o'clock Eastern Standard Time, or 4 o'clock if you're in the other eastern states, we'll finish up for today and then move on to tomorrow. So, all right, I will stop there and stop sharing my screen and I'll hand over to David.
Okay, so can help going to this.
Okay, is your mic on, David?
So whiteboard, where is my desktop one?
All right, we'll just try. So David, do you want to try and mute and unmute yourself again?
So that's this one. Can you see my slides now? Yep, okay, excellent. So good afternoon, everyone. So as Stuart said, I'm going to give a really very basic and hopefully quick introduction to current and future use of Earth observation relating to oceans. I was not totally sure what the audience would be, so apologize for a number of you if this is looking like quite an obvious stuff. And because my background and my domain of activity is in ocean color remote sensing, there might be a bit of a bias sometimes toward this technique, which is the one I know a bit more. And the last warning I would say is there might be probably a lot of omissions in this presentation as well. So don't be offended if your favorite type of Earth observation stuff is not fully represented. That's a workshop, I guess. So we are just here to have a discussion, and so take this introduction as what it is. So I will start with this. I called that slide my Earth observation shopping list, and as you can see, I have listed a number of parameters we can derive from phytoplankton chlorophyll to sea surface temperature, wave height, wave characteristics, sea height, thickness, etc., etc. And so you might think, what else? And is this the full list? Of course not. There are so many things we can derive now that it's absolutely amazing. And I started my career some 25 years ago, and we were just at the beginning of this development of this remote sensing activity, and that's just absolutely amazing what we can get now. So I will just quickly go through these 4 main data streams that I have identified as, the one which are the most used for research and applications for the open oceans. So sea surface temperature, ocean color radiometry, ocean surface winds, and ocean surface topography. And for each of them, I just have one slide, very simple slide, just to remind, what it is, how we derive this, and just a few slides to show what the situation is at the moment in terms of what's in space at the moment orbiting around the Earth. So as far as SST is concerned, and in each of these slides, there will be a number of websites that, of course, everybody can visit to have the full details. So SST, so that's basically the thermal infrared technique, which is getting this skin temperature, which can be related to what's happening a bit deeper in the water column, and depending on whether you look at this during night or during day, there might be a significant difference between both. So this technique has to consider all these things to end up with what has been called sometimes this sea surface foundation temperature, which is kind of a reference at 10 meters, which is something you can compare then to many of the validation data sets you would have from sea. And then you end up with these maps. I have just here this one from a relatively recent one from the Bureau, and the global sea surface temperature from the NOAA satellites. The SST missions timeline, as far as polar orbiting missions are concerned, is this very messy slide. So, these kind of slides are regularly updated, so I'm not totally sure this one is completely up to date, but basically the message here is, as you all know, and as you can see, there are many missions currently orbiting and providing SST. And that's only for the polar orbiting missions. So, European, US, Chinese, Russians, Japanese missions, etc., etc. Well, maybe, what I can say first for this kind of slides, they will always have this different color coding with what is currently in orbit, what is approved but might be waiting for launch, and what is only on the planning stage and pending approval. And that's what is not necessarily fully up to date. But basically the message here is, as you can see, there is a permanent process to try at least to avoid any gap in the time series from these different emissions parameters. And we can say that overall the international community has managed to go through this quite well, and very few data streams are at risk of a complete gap without any missions in space. And that's the same thing, but for the SST missions, but for the geostationary orbit. And here you can recognize the Meteosat program in Europe, the GOES, and in the US, the Japanese again, Chinese, Russian, Korean, and Indian streams of missions. The second parameter is this ocean color radiometry. So as you know, that's basically looking at how the sunlight, which is penetrating the oceans or coastal areas, interacts with any matter which is in there, phytoplankton, sediments, dissolved organic matter, non-algal particles, the bottom, if there is a bottom, reflecting bottom, and changing the amount and spectral composition of the light which is coming out of the oceans, and analyzing this in terms of those parameters. And what I have illustrated here is just a map of the chlorophyll of Western Australia. That's a MODIS image. And we take this for granted now, but again, that was such a revolution when we started to see this in the 1980s. And when you combine this into regional or global composites, and you can start to look at this at global scales and look at seasonal change, interannual changes, and then, decadal change when you have managed to accumulate enough of this data set. And again, here, this is the missions timeline for ocean color radiometry. As you can see, there is currently, or this green arrow, a good number of missions currently operating and many others actually in the planning. Of course, we have to be careful as well when we look at this kind of graphs, because not all these missions have the same characteristics, of course. Some of them are really global missions. Others might be collecting data on only specific areas. The technical capabilities are not the same as well. So sometimes it might be a bit misleading thinking, oh, this community, whether it's the SST or this one, they have so much in space, it's probably maybe even too much, who knows. But actually, when you look into the details, you start to realize that, okay, well, they really fully global missions with a long enough time span are not that many actually. Here I wanted just to mention in particular this PACE mission from NASA that could probably be launched in 2022, 2023, which is going to be another big step in our capabilities in ocean color with a fully hyperspectral mission, fully global hyperspectral mission, which will be the first of this kind. So quickly as well, so, you can see all these missions and think, okay, what has been driving this successive launch of instruments and how did they change over time? So that's the main drivers here are improving the radiometric quality. So as far as ocean color is concerned, you really need very high radiometric quality to go into the details of what you see. Improving spectral resolution, so having more spectral bands. Improving the calibration so that you can really maintain the quality of your data over the life of the missions. Vicarious calibration is specific to ocean color. More global data sets as well. Initial missions were just, providing a very incomplete coverage. Now we really want global data sets. And as far as ocean color is concerned, again, the move to having better and more information in coastal waters was a big driver as well. There are other drivers which are not technical or scientific, which are just basically that industry has to get contracts from governments and space agencies to do some work. And many countries and governments wanted to demonstrate capabilities, so to launch stuff. And this slide actually could be slightly modified, when it comes to SST or other parameters we get from Earth observation, but there would be a number of these drivers are basically the same. And, I just said, sorry, that this community wanted to have a bit more in coastal waters, and that's when this, what I call here a different flavor of ocean color radiometry is coming with higher spatial resolution sensors that here typically the Sentinel-2 MSI image above the Lucinda Jetty Coastal Observatory in Queensland. And as with this, of course, with this type of missions, you can start to address more local issues in coastal waters in particular. Not without some challenges, of course, because these sensors were not initially really designed for this. They were more designed for land applications. But there is a huge effort at the moment to use them as well in the coastal applications. The other parameters is the ocean surface vector wind. So that's essentially active microwave sensors, and the way the signal they send to the surface is sent back is indicating, is a function of wind speed and wind directions. I have just put here just two examples of individual satellite tracks and combination of them into a global map. And that's, of course, a very important parameter for anything which is related to weather and the physics of the oceans. Mission timeline, sorry, this one is a bit, well, it's not too bad, this one. Showing again that many countries have some sort of mission program, and which is extending to at least the next 5 or 10 years. And last but not least, the ocean surface topography, so the radar altimetry technique. So basically, as you need a radar which is sensing the surface, looking at how quick the signal is coming back to the sensor, indicating then if you have a very precise orbit determination and a very accurate geoid and ellipsoid information and everything. You can combine all these to get extremely accurate measurements of the sea level height. And from this, you can derive a number of information connected to ocean circulations at various spatial scales. And you can as well, of course, and everybody knows this, these curves have been shown so many times, derive this sea level change over decades. So that's maybe one of the most known technique, and one that has had one of the strongest impact actually on any oceanography from space work. And again, this timeline is definitely not up to date, but at least it includes what's going on at the moment. But basically, what is here in red, which is supposed to be only proposed, actually been launched. The JSON 6 has been launched, I think, 3 weeks ago. But all this stuff is actually existing at the moment and providing a continuity of radar altimetry. Okay, so what can we do with all this? And as you all know, science-wise, we can do a lot. There is, a real explosion of the community of research in the last 2 or 3 decades about using Earth observation for oceanography, basically. So physical and biological oceanography, circulation, air-sea and energy gas exchange at the interface, phytoplankton, spatiotemporal dynamics, productivity, the coupling between biology and physics, biotics research, ecosystem research, and so much more. And then in terms of applications, one of the main things is to use Earth observation as a head to modeling and to forecast systems. So that's on one side helping to validate what the model tell you, but most of the time to assimilate the Earth observation data into the models to keep them on their trajectory. You can do baseline assessments with all these different parameters, before when you know that something is going to happen in the environment that might change the environment. You might have enough of this Earth observation data to do a baseline assessment. Assessing carbon reservoirs and fluxes, working for fisheries, whether it's to help identifying potential fishing zones, helping with harvesting or with long-term sustainable management of fisheries, can look at water quality monitoring, state of marine ecosystems, hazards, etc., etc. So here I have just put one reference for as far as ocean color is concerned of a report which is going through all these possible applications. The question now is how much of this is actually operational, because that's the topic of this workshop. And actually, I would say still a rather small fraction actually of all these ocean-oriented satellite EO missions are part of really operational systems. With warning, when I say this, that of course this statement is highly dependent on what you mean with operational. So if by operational you mean just a mission that delivers qualified, validated products over a given mission lifetime without not many constraints in terms of timeliness, availability, continuity, etc., most current missions could be considered operational. Now, if operational means a guarantee of service over the long term, and generally with near real-time or even real-time data delivering capabilities, few missions are really operational in that sense. So the 2 main programs I'm aware of, which are considered as operational on the US NPOS and the EU Copernicus programs, which have a real commitment to maintain data streams over the long term. So there is a lot of literature about this. I have put just one reference here of a report from the National Research Council, the US National Research Council in 2003, not particularly new, but the issues behind this research to operations are still acute and being debated in this community. And yeah, that's to finish. Just a few slides on this. Is research to operation is kind of a concept, and you can see it probably in different ways. And here I just provide one example. It's just again from the same NRC report, where you have this, okay, on the left, the satellite research community, so instrument developers, research. In the middle, the operational satellite data providers, and on the right side, the user community, which might benefit from all these things for applications and services. And well, they have included in between what they call this valley of death and lost opportunities, which is basically to explain that this transition is not something that occurs naturally. So there is a lot of work and effort to ensure something like this. And this is just one way to see it, which is kind of relatively linear. Assuming that what is, things are going from the left to the right, and that's it. And there is another way to see this research to operation concept. I call it here the loop. And don't bother with this exact graph, which is on that slide. It could be many other examples. I just took this one because I think it expressed relatively well this idea that there should be some feedback and recurrent loop between research and operations, because research might benefit from what has become operational at some point as well, and what is operational needs regular improvements, and that's coming from research. So to some extent, my preference is to present this as this circular loop process rather than a linear one where you may think that once something is operational, that's it, it's going to run like this forever, and research can be dropped from the story. And this is an evolving topic. It's always a challenge. And I just realized recently that there was a specific conference on this in January of next year at the American Meteorological Society meeting. That's, of course, a virtual meeting again. And they have a specific conference on this. So that's really something which is discussed. And there is, I guess the message as well is, there is not a single model which is working for everyone. Each time some sort of research would be transferred to an operational system, there is, I guess, a specific model to consider. And sorry, yeah, that's the last. So, the producers of oceanics Earth observation sensor are, for the moment, most of the major overseas space agencies. And a large part of these come from NASA, ESA, NOAA, JAXA, and EUMETSAT. And at some point, Australia should probably and will probably be a provider. That's at least the current will of the Australian government with the new space agency. So maybe we will get there in a number of years, but Australia might become a producer of data as well. The consumers of this data are essentially state and Commonwealth agencies and departments, defense, and all sorts of marine related industries like, I mentioned fisheries and aquaculture, but they are of course not the only one. And the link between these producers, consumers, and the scientific community, which is working on this and allowing all these amazing products to be generated. It's a lot through ad hoc projects. It can be in Australia, like a linkage project with the ARC, or just specific activities that a given university may have with the Department of Environment in their state and these kind of things. The increased infrastructure and program are another way for these communities to be together, and I think it has been working quite well, in particular with IMOS. And there is the participation into science teams and into missions definition as well, which is a way to link the different communities. Probably many other examples as well, which I'm not necessarily aware of. And I think, yep, that's the last one.
Well, thanks very much, David. I mean, that's arrived at a really appropriate point there. Just to highlight a couple of things David had said in his presentation. What's operational is very different for different agencies, and that's something that we've seen a lot, whether it's groups that are responsible for state and territory or national vegetation monitoring and management, or keeping track of crops and other activities, or in terms of looking at fires, in terms of fuel load, and or actual monitoring of fire fronts. What's operational is quite different depending on the applications. So that's something we're not trying to prescribe an approach for everyone to follow. The second one is about that circular nature of research to operations. I think that's a really important point as well. What we would normally do at this point is just open it up to questions for a number of minutes and then just explain what we're looking for in the survey and then go through some case study questions. So we're interested now in some feedback in terms of what we've presented. You know, we're aware that there are a number of communities already that have well-established linkages along the lines of research to applications, but what we're looking at is how do we potentially bring these things together now, particularly in physical and biological oceanography, and also moving into terrestrial areas. The more effectively we present what we're doing and what we need, the more likely we are to be resourced at a national level as well. So Helen, you had your hand up. Sorry, I just had to get some context going there.
Okay. Hello. Can you hear me?
Yes, we can. Nice and clear. Thank you.
Hello. Well, thank you for a very nice overview, very quick, David. I noticed that you included the 4 main ocean type of variables that can be measured from space, and they are certainly the ones that in previous years I've thought were the main ones, but there are 2 others which I wondered if we were going to include in this exercise, and they are sea ice, all types of variables that can be measured from satellites, which are very important and becoming more important, especially to the Bureau of Meteorology and Antarctic Division, and also sea surface salinity, which I know we have very little expertise in Australia, but I think that's why we're not looking at it, because unfortunately I don't know anyone who's studying it. And yet maybe it would be really useful if we just knew how to use it. I know there's work done at NASA, and I have colleagues at NASA who have been studying it for several years now, SMOS and Aquarius prior to that, and there are new satellites to Grace, oh dear, I forget now. But anyway, yeah, are they going to be included, those?
Thanks, Hélène. As I said in introduction, I was pretty sure I would have made some significant omissions, and there are 2 important ones, definitely.
Yeah.
No, yeah, that has to be included. Yeah, for sure.
Yeah.
There's a lot to cover, I know, in one short presentation.
No, I mean, I think that's a good point, Helen. I think if there's any other key ones that people think we've missed, I mean, I'm sure other people would chip in a bit later on. I think, Helen, there were people at AIMS looking at salinity, and Jorg Hacker's group at Airborne Research Australia were also measuring that for a bit as well. But yeah, anything else to add in would help. I see Salman, you just unmuted yourself as well. Go ahead.
Yeah, so I mean, thanks for arranging this, and also David for the presentation. So I was just going to add over there from David's presentation. I think I kind of I kind of took that the 4 variables that David selected were the ones, just to show for the presentation, just a summarized version. But of course, in his first slide, he showed a myriad of different variables that are measured and are measurable. So of course, I guess I'll point out that under IMOS, there are now very long-term databases of wind speed and direction from spectrometers about 3 decades, from altimeters, wind speed, and wave heights, and also from synthetic aperture radar, which measures also wave-related parameters and directional wave spectra. So yeah, so I think there are still quite a lot of variables. So I'm sure that was not an exhaustive list, the 4 ones that David kind of went a bit into more detail. So yeah, so there is more room, I guess, and I think there is more work being done on other variables as well, the ones that I just mentioned, for example.
Sorry, just trying to unmute
Yeah,
myself. Thanks, Salman. Yeah, go ahead, David. Oh, you're still on mute. So I think, David, we can't quite hear you.
in terms of, whether it's would be a bit more relevant to the coastal applications and the other workshop, or in this mostly open ocean type of topics that would be appropriate. But that's something we can discuss, of course.
Thanks, David. I think we missed the first bit of that. That's all right. So just, I guess I'd open it up to anyone else to add in. Just while people are thinking, the questions that we're asking people to put information forward on help dig into this a little bit more as well. This is an area where a number of us who are coming from terrestrial and coastal applications don't necessarily work a lot, and we know that it's sometimes the professional societies and scientific organisations overlap, sometimes they don't. But I think we're approaching a time in terms of coordinated Earth observation in Australia where it would be good if we do get terrestrial, atmospheric and oceanic and coastal groups being able to at least present together in terms of what they're actually doing as well. So just open it back up to everybody if there are any other comments, questions or thoughts there before we keep going as well. All right. Okay, what we might do now is I'm going to spend a couple of minutes just doing a quick overview of what we're trying to achieve with this online survey form. I'm quite aware that people are a bit survey fatigued over the last 7 or 8 months from a range of different things, but this is a good way for us to engage openly and obtain information and then report back to the whole community. After that, we'll have a short break, and then we'll come back and I'll ask David if he can just do a couple of case study presentations as well. And I just want to say again, this is the start of a discussion. Ideally, we can link capabilities, whether it's Met Bureau, IMOS, our research organisations in state and territory, and Commonwealth governments a little bit more closely in these areas as well. So, all right, I'm just going to switch over to share my screen for a couple of minutes. So one of the main things we do with Earth observation for government network is try and consult as broadly as possible with people who are collecting different forms of Earth observation information and then processing it and delivering it, and primarily to look at, can this be used at a national level? The survey that you can see up on the screen at the moment is the same one that Larissa's just posted a link to in the chat window if you want to have a look at it. So the text just explains who we are, what we're doing, what we will do with your response when it's collected, and what we'll produce from this. And this is continuing the main approach in Earth Observation Australia, which is to obtain information from our communities nationally and then try and synthesize that to say, this is what we have and where we want to go, and use that to help with forward planning. So I'm just going to scroll through some of the things. Apologies, there's some typos in there as well, which I won't go into. Okay, so there's the start of the survey. It's in a number of sections, which you'll see on different pages. Just some details there. Okay, the first part's about products that you're actually using, and also if you're aware of, are there policy drivers if you're in an applications area. So this is in there because we're primarily coming at this from a Commonwealth level, looking at what activities are driving the collection and use of these products or services. We're also particularly interested in validation. This is something the terrestrial Earth observation community is really, I guess I'd give you my biased perspective, struggling with to coordinate because there's a range of different needs for it. And it does seem like there's more concentrated and focused activities, whether it's I guess ocean color radiometry, or you're looking at sea level or sea surface winds and wave heights for those things. So we are interested in validation, I guess, capabilities and what people are using. This is a particular interest to the Australian Space Agency in terms of supporting what we do in future, and that we've got access to those capabilities as well. And then just strengths and weaknesses of the products, and where would you like to see things go forward with these in future. The next section is about research. So this is where people are doing R&D type work. Some of that's in universities, some of it's in research organisations, some of it's in state and territory organisations that build and refine algorithms. Some of it's in Commonwealth areas, some of it's in industry and NGOs. But I guess we're interested in what you're dealing with that's research level, that's still being developed and tested and isn't quite operational, and what you think the priority topics are. This last part, and there'll be another question added in here, is about capacity building. And that's, some of you have probably just done a large survey for the Australian Space Agency and SmartSat CRC about what are the, what do we need to develop in terms of skills and knowledge for going forward in Australia in future. We're interested here in terms of, in your areas, are there skills and knowledge gaps that are there that we really need to have them addressed to help us move forward in these areas. So that takes you to the end of the survey. So that's a quick flick through the survey there. As I said, Larissa's posted that link in the window. What we'll do now is just have a very short break, given that we've been sort of sitting down for 50 minutes. And in 5 minutes, we'll come back and essentially enable people to go into the actual survey, and we'll also do get David to go through some more case studies. So back on again in 5 minutes. Thanks, everyone. So I realise with the survey, a number of people have already filled that out. So thanks very much for doing that. We'll come back to that a little bit later on now. Just to set some more context in terms of where we're going, I'd ask David just to present some current capabilities. So David, could I hand it over to you again, please?
Yep. Let's share this.
Yep, all good.
Okay, so the next series of slides is about just a few, of these use case or case studies, just examples of programs or activities we used significantly Earth observation for, a given applied objective to some extent. So there will be 4 of them. So the 2 are connected to IMOS. The third one is what the Bureau is doing. And the last one is this Copernicus Marine Environmental Monitoring Service. So the IMOS State and Trends of Australia's Oceans Report, or task team at that time, is a good example of, what Earth observation can provide in terms of, in that particular case, to look at, how our environment is at a given point in time, how it has been evolving over some of the past, and providing then a baseline and an assessment of the current situation. So that was basically the rationale of this task team, IMOS task team, which didn't use only satellite remote sensing. We used quite a lot of in situ measurements as well, but Earth observation was a significant part of it. And okay, the 4 bullets here, just to remind what the rationale for this thing was. So saying that marine assessments are important tools for examining the state and trends of marine systems at various scales. That IMOS was kind of uniquely positioned to do this, because it's a long-term, not so long for the moment, but that's the plan anyway, observing system. And that's intended to provide a baseline for contribution to all such marine assessments into the future. And the role of IMOS is precisely, it's an NCRIS program, so it's an infrastructure program which is supposed to build large data set and time series to be used and reused for this, typically for this sort of activities. So this is here, this table is show the list of parameters that were observed. And each column is for a given data source. So ships of opportunity, satellite remote sensing, moorings, animal trackings, etc. And as you can see, the satellite remote sensing was a very significant part of the assessment. And just 2 examples of what was done with this, where the source of information was only remote sensing. So on the left side, you have the SST trends over 1993 to 2016. Well, that's in, I think it's the degree per decade or something like this, which is shown here, which, significant increase in temperature in the southeast of Australia. And similar study using MODIS chlorophyll over 2003 to 2019. And the map you have here is again the chlorophyll trend expressed in milligram of chlorophyll per cubic meter per year, with very significant change occurring in all that southern part of the continent, well, the seas bordering the continent. The second example is again from IMOS, and it's the IMOS Ocean Current system and website. So that's basically a system, they analyze a number of satellite products. You see here SST and Ocean Color. And in particular, from looking at successive Ocean Color and SST observations, they derive current fields, as you can see on the image on the right around Tasmania. that's a website which is very well conceived, where you can just select, different parameters, different areas, different time span, and look at have a quick and easy look to what's happening in your favorite area. Typically, if we would have had a look, that was for the 5th of December, so that was 2 days ago, of the, I think that's the temperature fields and the currents here of Perth. This is what you would get. So, it doesn't look that much when you look at this, but actually there is a lot of layers of data processing, combination of different data sets, quite sophisticated analysis behind this. So between the raw SST and ocean color products and this information you can have on this website. Third example is, of course, the Bureau is a very significant users of Earth observation, and in particular for their marine and ocean forecast. And I have just copied here what you can get typically from their website. So you can have a look to the different areas around the country, or you can look at national, continental scale parameters. On the right side, you have this, again, temperature map around the southwest corner of Australia. Of course, this is mostly produced using models, but the satellite observations are key there because they are assimilated into the models, which is basically what you need to keep the model's trajectory within tracks. And then you can do valid forecast, and for more than 1 or 2 days. And that's basically what is expressed in these 2 slides that I have copied from a presentation by Boris Kelly-Guerin. And the slide on the top left is showing all the data source that the BOM is using to assimilate into their model. So you can see that they use a lot of this. And this instrument covers, mostly SST, but not only SST. And the slide on the bottom right is just to explain the importance of this assimilation of Earth observation data into the models to improve basically your capability to forecast from basically 1 day, or maybe a bit more if you don't have any assimilation, to a 4-day forecast that makes sense and which is valid. Using data assimilation. And we all know this because, when we look at the weather forecast, we know that 3 to 4 days, we can basically trust what they tell us. And that when it comes to, longer term forecasts, it's another story. But at least we have this time window now, which is really where you get excellent forecast. And the last example I wanted to highlight is this Copernicus Marine Environment Monitoring Service, so CMEMS. That's, of course, that's a huge program, was initiated maybe at least 15 years ago. That was called GMES at that time for global monitoring for environment and security, became Copernicus. And that's a huge program which includes a full space segment. There are this Sentinel series of satellites that you all know, which are supposed to be a series for the next decades. But from the beginning, that was conceived as a program to serve applications and services using Earth observation in particular. So if you go to their website, you can explore all this. They deliver all sorts of ocean products and ocean monitoring and ocean forecast. And they have defined a number of, as well, a number of use cases. And they have defined this in different markets. So they are listed here. So you can see from the marine food, science and climate, marine navigation, safety, disaster, water quality, everything you can imagine you can do with this data set. And if you look at their website as well, you can see that they currently have close to 200 use cases. And by a use case, they mean, an example of an application or services. Can be run by a private business, can be run by the government, can be run by a non-profit organization, or whatever. And it can be over these, different domains of applications and markets. Now, if you select in these things, what is really managed by small business, we would end up with 75 use cases, which means that still a large part of this is actually driven and taken by government agency, basically. If you would select marine food under the market type, you would end up with 25 use cases. So, it's a huge program. You still might think that having 25 applications running at the moment in this particular domain for a program of that size might still, that might still be a bit limited. But that's definitely something which is growing and growing. And we have to keep in mind that Copernicus is something like a multi-billion program across Europe. So that's one economic model which has been put together with a huge investment from the government. And for the moment, we could say a reasonable number of applications. Yep, I'm done with this.
All right, thanks very much, David. Just resize that. Right, and so that was, a good example of what's in place in Australia, and particularly from, I guess, the European context, what might be possible in some other areas as well. Just being conscious of time and where we are at the moment. So just to reiterate, we go back and look at this outline of where we are briefly. Okay, so we're in this first workshop, and the aim was to get an overview of a sense of what this area is. It is quite a challenging area because yes, we do have Commonwealth agencies like the Met Bureau of Meteorology, and we have a number of people from Met Bureau here today who are operationally responsible for those areas. We also have private companies working in those areas, particularly where there's oil and gas extraction networks and fisheries networks offshore. We have defence also working in those areas. As you come in closer to the coast, we get a slightly different mix of users in there as well. And then we've also got scientific communities which seem to be mixed in and work quite well with government and Met Bureau. And IMOS is one of our largest and longest running national collaborative research infrastructure programs, and it does have a substantive, I guess, satellite remote sensing component to it. So there's some linkages there already. What we would like to do moving forward over the next two workshops is look at essentially that the interaction of those push and pull factors that David identified in his slide from the the research side, in that we know there's a continual change in the type of image data that will be available. We're gradually seeing changes in processing streams, particularly long time series, large area data processing streams. We're seeing greater development of integrated modelling across a range of different domains as well, and increasing need for validation of these products and services. So the next two workshops are how do we start to pull out some of the key components there, recognizing that we may not have everybody that we need around the virtual table here, but we do need to make a start of it. I guess what I'm keen to know before we finish off with a conclusion for today, I mean, is this something that's already being done within IMOS or within the Australian Meteorological and Oceanographic Society or the Australian Marine Science, I guess, group as well, like where you've got people doing ocean colour, sea surface temperature, sea surface elevation, wave climatology, surface winds. Have we got somewhere where everybody's meeting together already? Or is this something people haven't done because, well, it's just too complicated and why do it anyway? So I guess I'm interested in people have some thoughts on that. David, I think, yeah.
Yeah, I could, by saying this, you makes me think that I probably should have mentioned within the IMOS arena, there are two activities. One is the ACCOMO, which is not sure I can get the acronym right, but that's the modeling. So that's basically a group which is looking at how all these data sets that IMOS is producing can be used to improve modeling. But that's still largely on the research side, but that's at least one channel for the observations to be used. And there is another group which is about operational oceanography. And this one I even have completely forgotten the acronyms, so I have a blank now. What's the name of this one? Anyway, there is as well
maybe sorry, David, maybe it's the Forum of Operational Oceanography.
Yeah, that's the one. Sorry. Thanks a lot.
No,
so
no
it's called FOO, F-O-O, Forum for Operational Oceanography. And that's, again, there is industry, there is the state agencies, Commonwealth agencies, and IMOS trying to see how IMOS can help and contribute to operational oceanography, and that's including, of course, the EO datasets.
I think Helen had her hand up, and then Salman after Helen.
Yes. Hello again. I am actually a little confused because I had a meeting last week with Agnes Lane and Lisa, and Agnes has been asked to do something kind of similar for the Australian Space Agency, sort of to survey users of satellite ocean data to see what could be done for CalVal. And I just wonder if you're talking to the Australian Space Agency about your survey and what you're trying to do, just so that, people are working together and not sort of repeating the same questions.
But I think, Helen, that's a really good question. I think I know where that response came from, mainly because I sit on the technical advisory group that Agnes is on as well. So this is actually partly for the civil space Earth observation roadmap, which the agency is trying to finish off. And one of the main activities that will come out of that is separating calibration and validation and being very specific about what we can do. So this is ideally meant to fit into that context and inform that process. However, it's still a challenge to make sure all of these activities talk to each other. And the other one, which I'm going to throw in, which Arnold might comment on, is the AquaWatch mission, which is actually going to be looking at, I guess, terrestrial, but as well as coastal water quality or water colour measurements. But that's also another one where, and David's also involved in this too, it's like, how do you keep the different conversations aligned? It is it's quite challenging, and I think we just need to accept it's going to happen and then try and make the connections as much as possible. I think the good thing, at least in Earth observation, is we do have there's a core group of people that sit in Earth Observation Australia and EOGN, which are trying to steer these things together. But it is hard to keep everything aligned all the time. So
yeah. And there are really very few of us in Australia that are
yes.
working in the observation of the ocean space.
Mm-hmm.
We far more who work over the land, but of course, this particular workshop is about the ocean.
Yep. Yeah. And so just on that question, Helen, about the linkage across, like I call it the physical versus biological oceanography. I mean, is those communities, I mean, do they actually, no, I'm sorry if this is an ignorant question, everyone. Do those communities talk in IMOS and other groups?
Well, at the IMOS annual planning meetings each year, there's only a little bit of time to talk about satellite observations. And normally, you know, it's about a new project, you know, something. Yeah. For example, the satellite wave database, that there was a presentation about that in a recent meeting, of course, because that's a new project. But no, there's not that much time. You know, it's a fairly short meeting. It's 2 days.
Yeah.
We don't talk a lot about satellite data because it's mainly about in situ data, I guess.
Yeah.
And at the FOO meetings, which are every second year, I offered to give a presentation, but you know, they didn't want it. I mean, they thought it wouldn't be of interest or something. So it was, they try not to have presentations by scientists at the FOO meeting because they know, you know, we'd bang on about the same old stuff and be boring. So they really want to talk.
It's not the same old stuff.
You know? So yeah, but it's I mean, in 2015, was it? Gosh, it was 5 years ago now. I held the very first workshop in Australia on users of ocean satellite data. You know, this is going back a bit. And at the time, we had about 100 people, and of those, a few students. It was hard to get people from interstate to Melbourne, especially students, because they didn't have funding. It was a 3-day workshop. It was very successful, and we covered the 4 main things that you've covered today: SST, altimetry, ocean colour, and winds, a little bit on winds, I think, but winds, waves. But they did say there, oh, it'd be great to have another one. And I didn't, said, no, I'm not doing another one. But what happened was Craig Steinberg at every AMOS and AMSA conference for the last 2 or 3 years now, it's been several, he's run an IMOS user data workshop, which is only like half a day or a day, but in that he covered the IMOS satellite data. So that was good. So I'd go along, or Pallavi, but so that sort of covered a little bit, but that's the closest thing I think we've had to a satellite ocean user data workshop since 2015. That's in Australia. Of course, there's ones overseas, like the operational satellite oceanography user workshop that I went to last year. That was in July in US, College Park, and that's going to be held again. It's going to be held every 2 years, and it's going to be at UMETSAT next.
So actually, that's where I was going with the next question. I'm conscious of time, but this is going down the path that we wanted to get to. So when you engage with you know, whether it's an ESA, you know, oceans science team, or, you know, a NASA one, or, you know, JAXA. I mean, is that usually on an individual scientist to scientist basis, or are you getting teams of people in Australia together?
International workshops.
Yeah. Okay.
Yeah. There was, we were going to have meetings. I remember Rob Johnson. Have you involved him in this?
Yeah,
Because
he
Rob
was
Johnson
earlier on.
was one of the people involved in the AMRSG.
Mhm.
But I never went to a meeting of them. I mean, there was a lot of talk. I think Boris Kelly-Gerain was involved a few years ago trying to start it up, and then Rob Johnson, but we haven't had a meeting. At least I haven't been invited to one since. You know, people haven't had time, I think.
No. Yeah, that's the challenge with this. And is there much contact with people in private industry that are doing, I guess, oceanographic data forecasting? No.
Really. Maybe through FOO.
Yeah.
I went to the last FOO meeting because it was in Melbourne last year, so that was really good. So I could go.
Mhm.
But normally it's held in Perth every year.
Okay. All right.
So, Stuart, this is Arnold. I do know that EOMAP is doing quite a lot of ocean work for energy and oil exploration companies and dredging companies, and they're just using, you know, their physics-based inversion system and just producing massive amounts of data for industry. So maybe we've got a little bit of a gap here in Australia, is that you know, we've got the public agency and the science agencies who are here online now. At the same time, we've got an industry group which is just operationalized a lot of this and is providing the data commercially, but the data is not available publicly in a very consistent quality assured form. Let's put it that way. It is consistent in IMOS, but there's some quality assurance issues. So that's an interesting aspect. I was just, I didn't know how much work EOMAP was doing till I had to search them for some other issues that I'm involved in. And then I found out everything they were doing in Australia, and it's quite impressive. The work they're already doing.
What's that organisation again? I haven't heard of it.
EOMAP. I'll put it in the chat window, or
I was wondering how to spell it.
So it's based, it's a company that came out of Germany that's done a fair bit of ocean colour, but from a radiated transfer modelling point of view. And so interestingly, so EOMAP's Australian, one of their Australian people, I did talk to Magnus last week. We also have people in consulting engineering companies that we've spoken to over the last year that do a lot of operational oceanographic forecasting, but it's in that area. It's time is money, and I mean we're all time is money. But, trying to get them to engage is quite hard.
The FOO meeting was a really great opportunity for me to talk to people in industry about satellite ocean data, I must admit, because, you know, they were there. And they are the sort of people who don't often come to ocean conferences like AMOS or AMSA. I mean, sometimes they do, but, you know, FOO is a bit more targeted, and the IMOS project office has made a point of trying to invite as much industry as possible, especially oil and gas, that sort of thing.
And actually
Oh, I can't hear you.
Dropped out again.
Yeah.
I think David and I are having some
weird. Oh, you don't hear me?
Yeah. Yeah, we missed that.
Now we do.
Now we do.
But I'm not speaking. No, sorry, I was just mentioning that FU was chaired by industry.
Yeah.
So it's chair industry and IMOS.
Yeah,
So it's
sure.
a clear
I mean,
view that it has
The
to be.
meeting is funded and organised by the IMOS project office because someone's got to pay for it. But yeah, it's got a board, and someone from the bureau is on the board, and someone from industry and IMOS, and yeah, it's fairly high level. But that might be,
Helen.
good to contact the IMOS director and just ask, how do you guys get involved?
So just on the Australian Marine Remote Sensing Group you referred to, which we all tried to establish 5 years ago, and Ron Johnson tried to play a lead role. But what happened is that at the Bureau, there was a reorganization and a reassessment of what they should focus on and not, and they decided to drop Ocean Color, to not go into Ocean Color operationally for all kinds of political reasons. And of course, that kind of then pushed, took the wind out of Ron Johnson's sails to lead this group. And nobody else took leadership because it involves time to get it up and running. Yeah. And I think there's a real necessity for it because what we've got, I just saw an image that David Antoine showed of Tasmania with high chlorophyll on the west, and it's not high chlorophyll, it's high colored dissolved organic matter. That's an issue that is a real problem, that we have to get it right. We have to get validation, we have to get trustworthy data, but we also have to discuss this amongst the teams that know how to discuss it, which is Thomas Schroeder up in Queensland, Curtin University people, other people at CSIRO in Tasmania, but also in Canberra, universities. They should all be involved, and we should have working groups, but nobody wants to lead a working group. They don't want to spend, they don't have the time to spend on it. And because of that, we get a lot of people spending time on products which may not be as good as they should be, or we get duplication. So in the end, we lose a lot of time and effort rather than invest a little bit of time and get great collaboration going across the country. And this is a weakness of Australia. Don't know how to solve it, because everybody needs funding nowadays. So if you want it to be coordinated, you want it to be funded.
And that's partly Arnold sort of hit the very large nail on the head with the small hammer that we have. But if we've each got a hammer and hit it, it's going to work. Part of the reason for the network is to draw together and to make this, to get a lot of return for a little bit of our time in this space. So I'm just conscious where we are with time today. This has been a really good start in terms of trying to understand where this could potentially go. We will do a follow-on discussion, which actually leads the point that we just got to here of we've got these disparate groups that work together in some areas, but not all areas. It's not a very big group. There could be ways of bringing that together so that we can go, these are the priorities in terms of what they're actually doing and what we need access to. And that would help with IMOS. It would also help with some of our terrestrial applications and atmospheric applications. Because one of the challenges we have with the Space Agency and other groups is you make requests for calibration validation, and they go, oh, but this group's already doing that. And the group's like, well, we're doing this much of this big bit. And they go, oh, but you're doing it, so it's okay. And we need to sort of get the terrestrial, the marine, and the atmospheric together to go, this is a very substantive capacity that a lot of our activities depend on, and we do need to support them more effectively. And we're almost at a place of doing that. And Helen, the discussion that Agnes would have had with you would have been about how that gets written into the Space Agency's roadmap for Earth observation as well. So I think we're getting there, but this is going to pull it together. So I'm conscious that we've gone over time. Thank you, everybody, for your time today. Especially thank you to David for getting those presentations together and bearing with the technical issues. Also to Larissa for putting stuff together today. We will be reconvening tomorrow, probably a similar group, and we'll look at what are the next steps for going forward. If you do have any questions, please send me and Larissa an email or David, and we'll get back to you. Otherwise, we'll see everybody tomorrow. Thanks, everyone.
Can you send the link for
Oh, yeah.
tomorrow? I didn't link
point.
tomorrow.
Larissa, can we send the link for the Zoom sessions on tomorrow and Thursday to everybody that's responded, please?
Yeah, because I didn't get it either.
Yep. Okay, we'll chase that up. Thanks for letting us know.
Sorry, I only just clicked on the register link today when I noticed it, when I checked my emails and went, oh, I was meant to actually RSVP with this link. So I was rather late to RSVP.
That's cool.
No
Well,
problem. We'll send those through.
Yep, cool. Thanks, everybody. That was really helpful.
Thanks a lot. See you tomorrow.
Cool.